Hello and welcome. So we are back with another video. This one is for my year 8s. We are doing percentages and the unitary method. This one, the name sounds really confusing, but when I thought about it, I actually used this method quite a lot when I was running some grade 11 chemistry classes. So it does actually have some utility out there. So we're first going to know what the method is, then use it to find a quantity from a known percentage. We're going to find a new percentage from a different percentage. Did I spell that wrong? I think I may have. Yeah, percentage is spelled wrong. Find the original price after it has been increased or decreased by a certain amount. So let's just quickly explain what the unitary method is. It's an intermediate step, meaning it's something you do to get you somewhere. It's not the be-all, end-all process. It's just there to find how much 1 unit of something is worth. What's the value of 1 unit? So, for example, and what I mean by unit, I mean it could be tickets, it could be sales, it could be people. Some sort of quantity that you're measuring with. So, here I've got a statement that says 4 tickets to a concert costs $100. So I've expressed that in maths here. So 4 tickets equals $100. And if I need to do some further work, the rest of the question is missing here, so that's what's happening. So what I'm just doing here is I'm dividing by 4 to see how much 1 ticket is worth. This is the 1 unit. And I have to do the same thing to both sides for this trick to work. So this will also be divided by 4, which gives me $25. So we now found the value of 1 ticket or 1 unit. From here, we can answer all kinds of questions. Let's say, how much would the price be for like 12 tickets, for example? We could quickly scale our answer up by multiplying it up 12 times to whatever we need to. So that's the beauty of the unitary method, is that we just divide everything down to a single unit, and then we scale the other number we have accordingly to what we need for our purposes. So that's what's going to happen here. So this is the actual full question here. I borrowed it from the book. So it says, this is the same as before. 4 tickets to a concert costs $100. How much will 3 tickets cost? Well, we already previously found that 1 ticket is $25. So all I'm going to do here is I'm just going to triple my answers here on both sides. Oh, that's supposed to be times, my apologies. So 25 times by 3 gives me 75, and there's their answer. So let's try a bunch. I did allude earlier that I have seen and used this method before with some senior students for chemistry class. We were dealing with chemical reactions, and it sounds fancy, but a lot of chemistry is just understanding the recipes. We call them a chemical equation, but think of them as a recipe. So that's why I've got a cooking recipe down here. And with the recipe, you often have to combine your ingredients in a certain ratio. Otherwise, you have too much salt or not enough water and things like that. So the proportions to one another of those ingredients really matters. It also determines how much of the cooking item you're trying to make is going to give you. Same thing in chemistry. We have oxygen combining with hydrogen and making H2O. They're going to do this in number ratios. In a lot of chemistry, we're just doing some maths to figure out how much water am I going to produce if I have this much hydrogen gas and this much oxygen gas, for example. Or I won't go into more detail than that, but that's basically what we're getting at here. And I did use the unitary method once upon a time on how to do things like this. So I've just pulled out a cooking recipe. Lately, I've been trying out this product here. We call it damper in Australia. I never really had it as a kid, but I tried it out recently. It's pretty good. So here's a quick recipe. I'm sure every recipe is a little bit different, but you got 6 cups of flour, 1 cup of water, 1 cup of milk, and here I think I had like a pinch of salt and a pinch of butter, which are marginal. And then we get like 8 servings of damper. I mean, 8 people could have something on their plate. So I know there's really large quantities here, but if you can understand the concept here, I know how much 8 servings is going to make, but I have 10 guests that I want to serve this bread dough. So what am I going to do to try to figure out how much flour I will need? So let's, basically we got this 6 cups of flour. I'm just extracting from the problem here. And I'm going to use this. I'm not going to use the equal sign. I don't think I use the equal sign here because they are completely different units to each other. This is tickets, this is dollars. So I won't be writing anything that's not mathematically true. If I hadn't written the word ticket and I just wrote 3 equals 75, that is completely false. That's not true. So I needed to make sure that the dollar sign is in there and the word ticket is in there. Otherwise, my equal sign would be false. Here, everything's measured in cups or servings here. So I'm instead of writing equals, I'm going to use this one here. So I'm treating it like a ratio. So here I got 6 cups of flour is to 8 servings of the damper product, the bread dough. And I'm just going to scale this one down so I know how much 1 serving is worth. So to get that down to a 1, I would divide this answer by 8, which would give me 1 serving. And for this side here, I would do the same thing to keep the ratio consistent. So divide this one also by 8. Now, this is not going to be nice and clean. 6 over 8, that is basically, what, 3/4 of a cup. Okay. Now we found out how much 1 serving of the damper is going to create. We need to scale this answer up to 10 times because we have our 10 guests coming. We want to have 10 servings. So this will be multiplying our answer by 10. And if we do that to this side as well, so times by 10, we should get 30 on 4 cups, which is roughly equal to, I think it's 7.5 cups when I punch it into some short division there. So there's our answer. We would need 7.5 cups of flour to provide enough for 10 guests. That's 10 servings. So that's where this can be used out there in the wild. I'm not aware of any other real world occasions, but this is something that just triggered my memory, and now you know. Right, so let's do some more of the basic ones that are from the book. So we've got, if 8% of an amount of money is $48, what is the full amount of money? So here again, I'm going to have 8% of some amount of money is $48. So here's my $48. Am I going to write this? I'm going to say no, because 8% is not the same thing as $48. I would need to, I don't know, it looks strange. So I'm going to use this instead. I'm going to put the ratio thing there, and I think people will understand what I'm getting at. We are going to scale this down, so we find out how much 1 unit of this amount of money is. So 1%, that means I've divided this by 8. I'll do the same to both sides, so that gives me $6 on the right-hand side. What's the full amount of money? Well, that would represent 100% of the money, wouldn't it? So we need to scale this up by scaling up 100 times. This gives us now 100. And we do the same thing on the right-hand side as well, so that would give us 600. And we're finished. There's our answer. So the full amount of money must have been 600. I'd write the full amount is, I would probably write as a sentence just to be sure on these questions. Here's another scenario, but slightly different. So instead of going back to what 100% is the full cost, maybe they might request us to just give it back in a different percentage instead. So it's saying if 11% of a food bill was $77, how much is 75% of the food bill? Okay, so similar process to before. So here's my 11% is to $77. I'm going to scale both sides down. So I find out how much 1 unit is worth, so 1 unit of percentage, and that should give me $7 on this side. Now that I've gotten to the unit, I can scale this up to whatever percentage I want. In this occasion, I have to go up to 25. So if I scale the left-hand side by multiplying by 25, I get 25%, of course, and I scale this one by 25 times, I think the answer was $175, I think. Let me just quickly punch in the calculator. 7 times 25, yeah, that's true. And we're done. So we don't always have to scale, like, it depends on what the question's looking for. Do we want to scale up to a certain percentage, or do we want to scale up to the full 100%? Depends on what the question is asking on the very end of the line here. Moving on, so here is a even more slightly complicated one. Mathilda bought a new watering can, that's this little purple thing she's holding, for her garden that was discounted by 20%. If the sale price was now $12, what was the original price of the watering can? So this one, we're using the same tricks. We are going to use the unitary method again, but we need to do a bit of working beforehand. So if it's already been discounted, so discount means to subtract. So it's the price has been has subtracted 20%. So now what we're looking at is current price is 80% now. Oh, sorry, 80%. Now I can do my unitary method just as before. So I can just write 80% is to $12. And now I can scale it all the way down to 1% if I really wanted to. And then I can scale that up to 100% to find what the original cost must have been. However, when I was sitting on this one for a while, I thought there might be a better way of doing it. If I was to scale, let me just rewind here a little bit. If I was to scale this one down to 1, that means I must be dividing by 80. On the left-hand side, that's pretty easy, but the right-hand side, I was thinking to divide this answer by 80, that would take a bit of effort here. I mean, it could be done. I could use some of my decimals tricks that I've done in a previous lesson. For example, I can move the decimal forward one space and move the decimal forward one space, and then I can use my short division to solve it. But then I thought, is there another way that I can do this that's pretty much that'll achieve the same objective but with less work? So it's not going to follow exactly the unitary method, but I was thinking, can I change this into something that's easy to scale back up to 100? If so, so like, can I divide it by, what if I divide it by 10? Then I would get 8%, and then that's really difficult to convert to 100. So I thought, okay, let's not try to scale it down by 10. What if I divided it by 2? That would give me 40%. And again, 40% is very difficult to scale to 100, so I'll keep thinking here. So I was like, well, what if I just divided it by 4? That would give me 20%, which is easily scaled back up to 100. Let me just remove these in between. So I like that one, and I also liked it because I can easily divide this with 4 in my head as well. It's just more convenient. So this should give me $3. Now I can scale both sides up to make it 100. So to change 20 into 100, I must scale that up by 5 times. Times that by 5, times this by 5. So the full cost must be $15, and that ends up being true. So a slight modification of the unitary method. So the modification step I've made here is I decided not to go all the way down to 1%, because in this occasion here, it did seem simpler to solve if I carried it down to some number that was more easily converted up to 100, which also allowed me to do some maths that's a little bit easier in my brain here. All right, that's basically all the tricks. I guess the only other trick I can share with you is what do you want to, if you want to check if your answer is correct. Okay, so if my answer is correct, then I should be able to put this into a calculator. 15, this is the $15 times by 80%. Does that equal the $12? Okay, so if I was to punch this into a calculator, I would do 15 times by 0.8. Why 0.8? Well, once you change this into 80 over 100 and you do some maths, you end up 0.8 anyway. So that is a way to just quickly confirm, and I believe I did that a few seconds ago, and that was the true answer. So 15 times 0.8 is $12. So it is the true answer. $15 must be the full cost. All right, that's the end of the video. Good luck with the questions.